Alright, so you want some examples? We'll give you some examples. And these example problems are basically going to concern looking at a Fischer projection and being able to determine if we have a D sugar or if we have an L sugar. So this problem really comes straight from the text. And if we take a look at the first example is basically a C double bond O and an H. And then we have a hydrogen down here at the bottom, and then we'll do an OH group here, and then we'll do a CH2 OH group here. So this is a true carbohydrate. We have a aldehyde up at the top, so it's an aldose. We have a total of 3 carbons, so here is my first carbon, and here's my second carbon, and there's my third carbon. So this is a triose. And then if I take a look, make sure that all of the carbons have an oxygen on them at least. The top carbon has a double bond O, so that one's okay. The middle carbon, it does have an oxygen in the form of an OH group. And then finally the last carbon, the CH2OH group, that has an OH as well. So this does meet the definition of a carbohydrate. We want to know, however, not what the carbohydrate is. We just want to know, is this the D form or is this the L form? And in the previous videos, we've discussed this concept of looking at the OH group that's next to last. So that would be this one, and figuring out whether that's on the left-hand side or right-hand side. And in this case, we see the OH group on the left-hand side. So I might be prone to label this as the L form of the sugar. But you have to be careful. And the reason that I'm saying that is because hydrogen is not on a left-hand or right-hand bond. Hydrogen is on either the top or the bottom bond. And remember, these hydrogens, that basically means that the group points away from you. So the template that we did as far as the shortcut goes of looking at the OH group and picking out whether it's on the left hand side or right hand side does not work here. And the reason that it doesn't work is because hydrogen is down here at the bottom. Hydrogen is not on the left or the right hand carbon on the carbon that needs that OH group. So the shortcut does not work yet again. So how do we determine whether this is the D form or whether this is the L form? Well, once again, like we said in the previous video, you take a look at the structure and you rank the groups on the chiral carbon. So there's the chiral carbon. Rank number 1 is the OH. That's a carbon, that's a carbon, that's a hydrogen. Rank number 2, carbon, carbon, hydrogen, so therefore these are tied. Then you go on to the next one. Well, this is an oxygen and this is an oxygen. They're tied again. Then you go to the next one. Well, this is a double bond, so I need to count that oxygen twice, and this one runs out. The only thing that's left is hydrogen. So this is rank number 2, and this is rank number 3, and this is rank number 4. So on the structure, I could do the model kit, use the model kit, figure out what the rotation is that way, or on a sheet of paper, what I would do is that I would rank them up, and look at the rotation here. So the rotation looks like it goes clockwise, right? So the rotation is clockwise. Now, typically, this would basically mean that this carbohydrate, because it's clockwise, is the R direction. And I just want to make sure that that really makes sense for what we've talked about before. So we said, number 1, you rank the groups that are bonded to the center, and we've done that. Number 2, you draw the arrows, group 1, group 2, group 3, and we've just done that. Now, if the lowest priority group is on a vertical bond, that's the kicker. So I'm going to come down here, up here at the top. Let's do it up here. So if the lowest priority is on a vertical bond. Now remember, vertical is up and down. So lowest priority is the hydrogen. And in this case, hydrogen is on a up or down bond. Then, if the arrow does point clockwise, like it does here, it matches. So this is a R sugar, or, if I wanted to, it's a D sugar. And that is how we determine the rotation. If the hydrogen is different, though, that's where we have the issue. So this is an example where the aldehyde was up at the top. Traditionally, the CH2OH would be down at the bottom, and the H and the OH would be left and right-handed. And this is an example where that template doesn't quite match. We can't just look at the position of the OH group and determine whether this is the D sugar or the R sugar. It's a little bit more complicated than that. So let's take a look at another example here. So let's take a simple sugar. Here's a chiral carbon, and this time let's put my carbonyl down here at the bottom, and let's put the hydrogen up here at the top, and let's put the OH group here, and then let's put the CH2OH group there. Okay, so I've just kind of turned the molecule around on you, put the groups at different locations, and we're going to kind of go through the same description here again. So does the shortcut work? The answer is no. The reason the shortcut doesn't work is because aldehyde or ketone will be up at the top and my CH2OH will be at the bottom. And in this example, that's not the way that it's drawn. They've twisted it on me. They want me to think about it a little bit more. So the process and the rules are all the same. Right? You take a look at your chiral carbon and you rank the groups. Here's OH ranked number 1, my C double bond OH is ranked number 2, my CH2OH group is ranked 3, and my hydrogen is ranked 4. I then look at the way that I've ranked them and I do a rotation on it. So number 1, and then number 2, and then number 3, and then number 4. So there's the rotation around the chiral carbon. Now, at first glance, it looks like this is a clockwise rotation, right? So clockwise rotation probably means that this is a R sugar. However, this only matches if the lowest priority is on a vertical bond. And my lowest priority here is hydrogen, but it's on a vertical bond, right? It's going straight up or straight down. It's going straight up in this case. So this is a R sugar, or if I wanted to label it, it is a D sugar. So yet again, another example of how they will twist and change these structures up on you to make you think a little bit on what kind of rotation that we have on our hands. So let's take a look at a third example, and this example, let's do the CH2OH group up here at the top, and then let's do a C double bond OH down here at the bottom. Let's put the OH group on this side and the hydrogen there. And we want to know what type of sugar is this one. Alright, so if I look at C, it doesn't match my template. It comes close, but it's not an exact match. And the reason is because the aldehyde or ketone has to be at the top, and my CH2OH has to be at the bottom. So my template and my shortcut will not work here. So I really do need to go in and label the priority groups here. And the way that I do that, again, OH is priority number 1, and then the aldehyde, and then comes the CH2OH at number 3, and then hydrogen at number 4. Okay, so there's the structure and there's the group ranking. So I start off with group number 1, and then this turns to group number 2. Okay, so if I just look at this first turn, because it kind of gets a little weird here, right? I mean, I can't continue on to 4 and then 3. 3D, though, it allows me to do this in a way, but on a sheet of paper, I might get confused. So just look at the first turn. Number 1 and number 2, this is counterclockwise. So counterclockwise basically is going to tell me this is the S sugar, right? The sinister version, not the R, but the S, or the L sugar. Okay, but that only works if the lowest group priority-wise is on a vertical bond. And if I look at this hydrogen, it is not on a vertical bond. So we have an issue here. It is not a vertical bond. Right? And because it's not a vertical bond, it doesn't match. Okay, so here's where the trick lies. These are the ones that you will get wrong if you attempt these problems and you go too quick, because you've got to think about it for a minute. The hydrogen is not on a vertical bond. It doesn't point straight up, it doesn't point straight down. It's off to the left or right. Traditionally, if it is pointing straight up or pointing straight down, the rotation matches the sugar. But because the hydrogen is in the opposite location, it is the opposite turn. So because it's not on a vertical bond, this actually is not an S sugar and it's not an L sugar. This really is a R sugar or a D sugar again. And once again, the reason is because of that lowest priority group. It is on a horizontal bond, not a vertical bond. So if the hydrogen is on the up and down position, the rotation around the center carbon matches what you've drawn on the sheet of paper. If the hydrogen, though, is to the left or to the right, then this is not the way the rotation exists. It is the opposite. So in this case, it looks counterclockwise, and we would traditionally say that is the S rotation. Hydrogen's in the opposite spot, so therefore the rotation is opposite of what we would think it would be. So we think it's going to be the S form, but because of the hydrogen location, it actually is the R form or the D form instead. So that's how you'll answer those questions. These things take a little bit of practice, but you know, that's what the homework's for, right? The homework will walk you through a couple of these problems. It will kind of get your feedback and kind of give you input on what you're doing wrong and maybe what you're doing correctly. So take a look at your lowest priority group. It will tell you how the rotation exists, and I think that you'll be okay from that point on. So this is the end of the examples as far as looking at the Fischer projection and determining if it is D or L. And we're focused on the Fischer projections that don't really match the template, right? The shortcuts were easy. You look at the OH group, is it left hand, is it right hand? But if they twist and turn the molecule and draw these structures at different spots, well, it takes a little bit more effort on our part to determine what type of rotation this thing is going to be. So in the next video, we're moving on, and now we're going to move on and we're going to take a look at more configuration, and then we'll quickly go into maybe some of the common carbohydrate structures that you should be aware of and that you should know. So that's coming up in the next video. Stay tuned, don't go anywhere, pop you some popcorn and come back.